This is the fourth experiment of Compiler Lab, and in this experiment I'm going to talk about token separation using LEX2. So I have to create a LEX program which does the lexical analysis of the token separation program. So let us go and see the code. So I have done this LEX program. Uh, so there are a particular format for doing a LEX program. First of all comes the definition. So I have some count variables for keywords, operators, punctuations, and identifiers. So I'm initializing those keywords, those count variables to 0. Now I have some definitions. So as you can see here, I can name the definition and I can define it within the square brackets. So punctuation I have defined as pound. So this is my definition name, and semicolon, comma, hyphen, uh, inverted commas. These are all the functions. These are all the punctuations. Now I have defined operators like addition, subtraction, division, multiplication, equal to. All these comes under the name OP. I have created a space definition also for space, tab, and new line, and then identifiers from A to Z, capital A to Z, digits 0 to 9, and positive closure because it can be one or many. It can be occurring more than one. So positive closure comes. Now to end this declaration part, I have to use a double percentage sign. And next comes the translation rules. So in this, I have to perform some operations when each keyword or each definition comes inside the content of the file. So like if int comes, if int comes in the file, the count variable, keyword count variable will be incremented, and int is a keyword, that is the token will be uh, printed. And this token actually is stored in YY text. YY text is nothing but it it stores the current value inside it. So like float, I'm again incrementing keyword count, and I'm saying float is a keyword, and this is stored in YY text, and then it is printed. So likewise for each and every definitions that I have defined above, and also for the keywords, I am doing some operations for corresponding to those keywords and definitions. So to end this translation rules, I have to again put double percentage sign. Now here my main program started. In the inside main, I have to call yylex function. This yylex function is the main function which starts the whole lex program. If it is not there, the lex program will not be started. So after starting the lex program, after doing all the operations, I am printing here number of keywords, number of operators, number of punctuations, as well as number of identifiers here. And to return and to stop the lex program, I have to use ywrap function, which returns 1 at the end. So let us see the output, how it's coming. So to run the lex program, we have to use lex keyword here, lex toxer, which is the name of the program. So since it's a C program style, so we have to use CC to compile it. Lex dot yy.c. Now to print the output, we have to give dot slash a dot out. So I am writing here int a comma b equal to 10 semicolon. So when I enter here, as you can see, the token separation is happening. Int is a keyword, a is the identifier, comma is a punctuation, b is the identifier, equal to is the operator, 10 is an identifier, semicolon is a punctuation. So in this way you can do the LEX program. I can see some other keywords also, double x equal to 10. So again you can see here double is a keyword, x is an identifier, so it's all defining as per the LEX program. So in this way you can do the token separation using the LEX program. Thank you for watching my video.